Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from summer 2022. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 24 to 26, which account for 12 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 24. In a factory, 6 identical machines can make 3,000 erasers in 2 hours. How long would it take 8 of these machines to make 1,000 erasers? Okay, so if 6 machines make 3,000 erasers in 2 hours, then 6 machines make 3,000 divided by 2 erasers in 1 hour. Okay, so it's 1,500 erasers in 1 hour for 6 machines. We're going to divide that by 6. So we're going to see how many each machine makes. So one machine is 1,500 divided by 6. So let's figure that out. 1,500 divided by 6. 6 into 15 is 2, remainder 3. 6 into 30 is 5, so that's 250. So one machine makes 250 in 1 hour. Okay, so that's 250 in an hour. So how many machines is 1 hour? So 8 machines make 1,000 erasers. Well, if we times this by 8, 250 times 8, 8 times 200, 8 times 50. Okay, so that's 2,000 erasers in 1 hour for 8 machines. We're only looking for 1,000, which is half of that. So we're going to say it would take 30 minutes for 8 machines. (25a) Expand and simplify 4x add 5 multiplied by 2x subtract 1. I'm going to use a grid method here just to organise my work a little bit. You might use FOIL or another method. So my first bracket, 4x plus 5, and then 2x minus 1. So it's a multiplication. 4x multiplied by 2x. Well, 4 times 2 is 8. X times x is x squared. 4x multiplied by negative 1. Well, a positive multiplied by a negative is a negative, so that's negative 4x. 5 multiplied by 2x gives us 10x. And then 5 multiplied by negative 1, a positive multiplied by a negative gives me negative 5. So I have 8x squared. And what I'm going to do is I need to combine like terms. So this diagonal, these x terms need to be combined. So I have 10x subtract 4x. 10 subtract 4 is 6. So I'm left with positive 6x. And then I've got subtract 5 on the end. Part B. Factorise. X squared subtract 10x add 21. So this is a quadratic here, so it's going to factorise into 2 brackets, and I know it factorises into 2 brackets because I have a squared term and then that constant number term on the end. So I'm going to put it into 2 brackets. Each bracket's going to have x because that's how I'm going to get my x squared. So now I need to look for 2 numbers that multiply to give me 21. So 1 and 21 and 3 and 7 are my options for pairs of numbers. But what I want to happen is when I multiply them, I get a positive answer. But then when I add them, I get negative 10. So the only way I'm going to get a positive answer is if both of these brackets are positive or if both of these brackets are negative. Now, if both of these brackets are positive, 3 plus 7 is positive 10. That's not going to work for me. So I need these brackets to be negative. So I've got negative 3 and negative 7. Okay, part 2. Use your answer to part B to write down the solutions of the equation x squared subtract 10x add 21 equals 0. So this is the quadratic that we worked with here, and what we've done here is we've factorised it. So that's the first step in solving by factorisation. Now if this quadratic equals 0, then we can say that x subtract 3 x subtract 7 is equal to 0. So for it to be equal to 0, these brackets being multiplied together, each bracket must equal 0 at some point. So if x minus 3 equals 0, we can solve that for x equals 3. If x minus 7 equals 0, we can solve that for x equals 7. And that's our solutions. Question 26. Vikram wanted to find out how many moths there were in a small woodland. One night, Vikram captured a random sample of 12 moths and marked them. He then released them back into the woodland. The next night, Vikram captured a second random sample of 30 moths. He found that 9 of these moths had been marked. Vikram estimated that there were 40 moths in the woodland. Show that Vikram's estimate of the number of moths was correct. So this is called capture recapture. Okay, guys, so we need to be aware of this formula. M over N equals R over T. You may have seen it differently. This is the one that I use. So M is the total marked. Okay, so the total marked in this first sample here. So 12. So there were 12 total marked. N is the total population. We don't know that. Vikram reckons that it was 40, but we don't know that yet. So N is the thing that we're looking for. R is those that are marked on the recapture. Okay, so on that second sample, 9 of the moths had been marked. And then T is equal to the total second sample. So it was 9 out of 30. So we're going to use this now to solve for N for that population. So what we would do is, if we multiply this equation by N, we have 12 equals 9N over 30. Then if we multiply by 30, 9N equals 12 times 30. So 9N equals 360. N equals 360 divided by 9, so N equals 40. So we've shown that his estimate is correct. Part B, comment on how reliable Vikram's estimate is likely to be. So we're going to say, let's look at these sample sizes, okay? 40 is the estimated population, but he captured a sample of 12. So actually his first sample was quite small compared to his second sample. So I'm going to say it may not be reliable as he only captured 12 moths in the first sample. So it may not be reliable. He only captured 12 moths in the first sample.